Hello everybody, welcome to Mastering Solutions. In this question, we have to figure out what the wavelength of the light is for this diffraction grating. And we're going to be using the equation sine of the angle is equal to m times lambda over d. Now, we don't know what the lambda is. Obviously, that's what we're trying to solve for. And I want to go over again, we talked about it in the last question, but I want to go over how do you find D. Sometimes I think it's really confusing and it's easy to get kind of turned around and twisted up on how to solve for it. All that you do is you take the width divided by the slits. So in this case, we have 750 slits per millimeter. So for this, we have 1 millimeter divided by 750 slits. So let's put that at 1 times 10 to the negative 3 meters divided by 750 slits. So for every millimeter, we have 750. And so that is how you find the D for diffraction gratings. Most of the time, I'll see students flip these and they'll try to do 750 divided by 0.001, and it's kind of confusing. So width divided by slits. Now, what we're going to do is we need to solve for lambda, so we need to isolate this. So if we multiply both sides of the equation by d, we'll have d sine theta is equal to m lambda. And then if we divide both sides by m, now we'll have lambda is equal to d sine theta over m. In the question, though, they say it's a first order diffraction angle, and so m is going to be 1. So really, we can simplify the equation to d sine theta because m is 1 in this case. If m is something different, that would stay there. So now all we have to do is plug everything in. So we figured out that d is this value here. So 1 times 10 to the negative 3 meters divided by 750 slits. We'll multiply that by sine of the angle, which is given to us as 34 degrees. So a note, since this is given in degrees, make sure you change your calculator from radian mode to degree mode. It has to be in degree mode for this question. So when we plug that in, we have 1 times 10 to the negative 3 divided by 750 slits. And then that is D. We're going to times that by the sine of the angle 34. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 46 nanometers because it's 10 to the negative 9. So that is the wavelength of light for this diffraction grating, which coincidentally in this case happens to be red, which I didn't intend to do that.